We have talked extensively about polar coordinates, polar equations, and now we're going to talk about the slope concerning polar things. So let's just jump straight down here to the example, and then we'll come up here and dabble in this box of explanation later. So given that r equals 3 sine of 4 theta, so let's just unpack this briefly. The radius is a function of theta. We do something to theta and we get a radius. So this first question that says, what is the rate of change of r with respect to theta? Okay, there's nothing funky that needs to happen here. There's a lot of funky that's going to happen on this one. Nothing funky here. This is just a regular straight up derivative, and that's what this says. The derivative of r with respect to theta is r prime of theta. That's it. That's all you need. So we're just going to switch to purple, no reason, and take the derivative of this. So r prime is equal to, all right, the derivative of sine would be cosine, so it's 3 cosine of 4 theta. However, chain rule, multiply by 4, so the 3 times that 4 is going to give me 12. That is my derivative. So I want to evaluate the value of the derivative at pi over 6. So we'll just plug this in, use our knowledge of the unit circle. So 4 theta times pi over 6, that would be 4 pi over 6, essentially. That's 2/3 pi. I need to know what the cosine of 2/3 pi is, just so we can have a visual. I'm going to write it. Write one more step here. There we go. Cosine of 2/3 pi is, let's see. I don't know what the circus music is for. So this would be 1/3, 2/3. Cosine 1, square root 3 over 2, square root 2 over 2, 1/2. 1/2, but it's negative 1/2. So 12 times negative 1/2 is going to give me negative 6. Found it. All right. Now things get different because they're asking things in a different way. I'm looking at this and I'm thinking, that's a little confusing. That was 1/3. That's 2/3. That's 3/3. Okay. Anyway, back to this one. What is the slope of a line? A line? Okay. This is polar. These are generally curves. And this is asking for the slope of a line, just a line. So this is going to involve x and y. And so I'm going to have a different set of skills for this one. And here's the scales. Here's the scales I have. Here we go. The slope of a line tangent to r theta at some point r theta is the derivative of y divided by the derivative of x. Okay, this is going to really start looking parametric. You've seen this. That would be dy dt over dx dt, right? Okay, parametric. Parametric, you with me? I'm stalling while I dig out some old notes that'll explain this. You see it? You see it while I stall and look for old notes? Do you see it? Do you see it? And you start pressing the forward arrow. Oh, please, explain. Explain it. Here we go. Got it. First derivative of a parametric equation is dy dt over dx dt, as long as dx dt is not equal to 0. Well, now I'm dealing with y as a function of theta and x as a function of theta. So we're going to do dy d theta over dx d theta. All right, good to remember. So let's come over here with a black pen and write it. If I am converting from polar to rectangular or rectangular to polar, I have a specific set of equations I need to know. So x is equal to r cosine theta, and y is equal to r sine theta. What you see right here is showing up right here. Now, it's not just r sine theta, it's going to be r of theta, because r is a function of theta, and r of theta sine theta. Okay? And notice this is an extension of the product rule. So if you're like, I'll never remember all this, you don't need to. You really don't. You don't need any of that right there. What you need to know is this. You already know it. Take the derivative of it. Ooh, product. Take the derivative of that. Product. Let's move on. Slope of the line tangent to r at theta equals pi over 6. Well, let's hold off on that pi over 6 for now. And what we're going to do instead is switch to green. And we're going to eventually find dy over dx, because that would be the slope of a tangent line, right? So x is r of theta cosine theta. So I'm just going to write that. That would be 3 sine 4 theta cosine theta. That's good to know, okay? And I'm going to go ahead and find the derivative of that. So dx d theta is, okay, we're going to clean this up a little bit. It's going to involve the product rule with some chain. It's going to be great. So f prime g plus fg prime. So f prime of this, we've already taken the derivative of this actually, and we ended up with that. So there's this one, 12 cosine 4 theta. F prime g plus f g prime. There we go. And now we're going to deal with y, and y is equal to r of theta sine theta. So we're going to have 3 sine 4 theta sine theta. Okay, it gets a little sloppy, but that's okay. So we found dx d theta, now we're going to find dy d theta. And that's going to be product rule, f prime g plus fg prime. It's going to look a lot like what we just did because f prime, the derivative of 3 sine of 4 theta is, oh, we found it up here in a different context, but we found it. So 12 cosine 4 theta, f prime g plus f g prime. Okay. And now we're ready to find the slope of a tangent line at a specific value. So what I want to do is evaluate, running out of space here, I'm not write big like that. Let's switch colors too, just because we're moving on to a slightly different idea. Let's go to blue. Not a different idea fully, but dy d theta over dx d theta. Now, if you want to simplify that and call it dy over dx, fine, you can. Evaluated where theta equals pi over 6. Looks like these two lines run together, and they shouldn't technically. So they shouldn't technically. There we go. So this is going to be, well, dy d theta divided by dx d theta, and I'm going to plug pi over 6 in for that. I'm going to do as much of this as I can without a calculator. It's going to get nasty, y'all. It's going to be gross. So bear with me. I'm going to go fast. Dy d theta, where I plug in pi over 6, going to do a lot in my head also. So 12 cosine of 4 pi over 6, that would be 2/3 pi. We've actually already addressed this issue here. Sine of pi over 6 plus 3 sine of 4 pi over 6, that would be 2/3 pi, plus cosine pi over 6, all divided by. All right, it's about to happen here as well. It's going to be gross. 12 cosine of 2 pi over 3. We already know that to be -6, by the way. We found that out earlier. See? Told you. Sine. Oh, nope. Cosine. I should be here. Dx d theta. Cosine. There we go. Pi over 6 plus, minus, I'm thankful for whiteout, minus 3 sine 2 pi over 3 sine pi over 6. Okay, let's do some stuff in our head. This was -6, because, well, we know that. So -6 and -6. I'm looking there and there. All right, sine of pi over 6 is 1/2. I'm double checking some things. Hold up. Yeah, I'm right. Okay, plus, I'm scared to death I'm gonna make a mistake. You're like, no, I gotta start the whole video over. 3 sine of 2 pi over 3, sine of 2 pi over 3, square root of 3 over 2, is 3 square root of 3 over 2. 3 times the square root of 3 over 2. Whoops, that shouldn't be plus, that should be multiplied. My apologies. We put a little times in there, fill in that gap. Cosine of pi over 6 is square root of 3 over 2. All divided by, let's see, we already got a -6 out of that. Cosine of pi over 6 is the same thing we just had right there. That'd be square root of 3 over 2. Minus 3 times whatever's about to happen here. Sine of 2 pi over 3, square root of 3 over 2. Yep, those two should match up. And then sine of pi over 6 is 1/2. Okay, I said we do as much as we can without a calculator. We're going to have to use a calculator here in just a minute. But in the meantime, let's keep moving. let's see, we have negative 3. I'm gonna run out of space. It's gonna be tragic. Negative 3, that is 3 times square root of 3 times square root of 3, which is 3 times 3, which is 9, 9 over 4, plus 9 over 4, over, this is negative 3 square root of 3, because that 2 cancels there. And let's see, we have over 4, so minus 3 square root of 3 over 4. Okay, I think we are far enough to where we can type some things in our calculator. Let me grab my calculator real quickly and figure this thing out. I'm having a blast, y'all. It's just fantastic. Negative 3 plus 9/4, and then negative 3 square root of 3. At this point, it's just calculator stuff that requires no calculus, so if you want to kind of take a brief nap while I type things in, no one's going to be offended. There we go. We're going to take this and divide it by that. You can go up and retrieve those, by the way. And that's what I got. That is the slope of a tangent line at that theta value. Fun, isn't it? It looks a little complicated. Don't worry, it won't be that bad.